the formula V equals that, where the value of the car is V pounds when the age of the car is T years. A sketch of T again. State the range. Ooh, the range. Okay.
So so this is the thing. Me and Ruby got this one, but we don't understand how we got it. Which is really weird. But we got it right, but we don't understand how.
Well,
So,
to help you with this one, you can see that as T gets bigger, the value of V gets smaller, right?
yeah.
And we can see on the graph physically that when T is at its smallest, that's when the value of V is highest.
Yeah. So we did T when T equals 0, what V would be. But then we put that the range was wait, actually I forgot what the answer was. I can't find the paper on my iPad for some reason. But 18,000 plus 4,000.
Well, if you think about it logically,
yeah,
you can even use a calculator. What is the value of if you look at 18,000 e to the power of minus 0.22, we can see that because it's a negative power, as T gets bigger, that function is going to get smaller. So if you put in a really large value of T in, what kind of value are you starting to approach? And I'll let you guys try this on your calculator.
Are you approaching 0?
Yeah. So we can see that with the 18 e to the minus 0.22, that approaches 0. What about 4,000 e to the minus 0.1 t?
Is it the same?
Yeah. So as T gets really large, the first two things approach 0. So then if you look at the function as a whole, what value does the function approach?
1,000.
Yeah. So we can see the range is the lowest value, the highest value, whatever that is the upper limit. And then the lowest value is the lower limit, but you've got to be very careful with the inequality signs. So if you put in T equals 0, what is that? You have e to the power 0, e to the power 0, that's 1. 18,000 plus 4,000 is 22,000. So at T equals 0, V equals 18,000 e to the power of 0 plus 4,000 e to the power of 0 plus 1,000.
E to the power of 0 is just 1, right?
Yeah. So then that equals 18,000 times 1 plus
23,000
times 1 plus 1,000, yep, which equals 23,000.
So how did you interpret the fact that when T gets greater, the value? So is it just the graph?
Yeah, the graph. The graph shows you, but you can also just try it out. Like try it on your calculator. Try in big values, try in small values, try 0. I one just it gives you get a feel for what the function's like. So I've sent the Jamboard link again for anyone else who needs to get onto it. So yeah, honestly, when you've got a function and you need to think about what the graph looks like, good thing to do is just try some values out. Try out some negatives, try out some positives, try out 0, try out some really big values, some really small values. I guess in this case, we didn't have to try negatives because t is greater than or equal to 0. But honestly, you're just trying out stuff. And that's me assuming that you have a basic calculator, but I know you guys don't have a basic calculator. You could even use your calculator to graph the function to get a rough shape of what it looks like.
How would you graph a function, an exponential function?
What, on your calculator?
Yeah.
I'm not gonna lie, I'd probably have to YouTube it. Yeah. I can find your YouTube video and then send it.
That sounds nice.
Yeah, at this stage, I wouldn't even lie.
So would it be v is greater than or equal to 23,000 and less than or equal to 1,000?
Well, that's impossible for those two things to happen at the same time. Hear what you said and say it again.
Oh wait, no, sorry. Sorry. V is greater than or equal to 1,000 and less than or equal to 23,000.
So range is the 1,000. Wait, say it one more time.
V is greater than or equal to 1,000 or less than or equal to 23,000.
Okay. Let's just evaluate this answer. Let's do a poll. How many people agree with that answer? I'm guessing one person agrees because one person said it. But who else agrees? Wait, no one else agrees. So what do you guys think?
I was doing another question.
Oh, okay, fair enough. That's a good enough thing to say. What do other people think? Do we agree?
Would it be that it's greater than 1,000, not greater than and equal to?
Why'd you say that? Yes, I am being that guy.
Or because is it it's saying that that t is I'm not sure.
What were you gonna say?
It says t is greater than or equal to 0, but I don't know how that helps.
Oh, you were saying it says that and then you stopped.
No, I said that t is greater than or equal to 0. That's what it says next to the equation, but I don't think that helps.
Yeah, because when it's 0, that's when we get its value of 23,000. But how did we get that 1,000?
Limits.
Limits. What is a limit? Okay, that's a bit of a hard question, but no, it is as in like for the proper rigorous definition. But loosely, what is a limit?
When a value of a thing approaches a certain number.
Right, but does it ever equal it?
Right. Okay.
So that's the idea.
Okay.
So we can only approach 1,000, never equal it, because we only truly get 1,000 when t is infinity, but t can't actually be infinity.
Mm-hmm.
So it's only getting closer and closer, but never touches it. So really, we've got that inequality there. V is in between 1,000 and 23,000, but does not include 1,000. So that's the range of values. Cool. For part B, find the rate at which the time value of the car is decreasing. Oh, sorry, at which the value of the car is decreasing when t equals 10. Give your answer in pounds per year. So here we've got to do differentiation.
Sorry, I'm just writing down why it's not equal to. Okay, you find the differentiation of it, and then
The derivative. Yep. Mm-hmm.
yeah, derivative. Sorry, I don't know the differentiation.
So good.
Please.
I'm bad with. Okay, wait. So
Does anyone remember how to differentiate E?
I don't remember.
Anyone else? No?
Does E stay the same when you differentiate it?
That is true. So at the most basic, if y equals e to the power of x, then dy dx equals e to the power of x. What about if you had something like this? What does dy dx equal here?
The same.
Not quite. With this one, it's going to be 2 e
Yeah.
to 2x.
Right.
What about if y equals e to the power of minus 3x? What's dy dx going to be there?
Minus 3 e to the power of minus 3x.
Mm-hmm. And so on and so forth.
So you differentiate, but you don't change the value of the power.
Yeah, that's right. Well, yeah, more or less.
Why does the power not change?
Well, that's something that
Or is
we'll
that a
get
hard
into.
question?
It's like the answer to it is something that goes beyond what the understanding of AS requires. To get a bit more of an insight, this is where we use something called chain rule, but that's second year. But if you're interested, you can check out my videos.
Alright, I will.
Yes, that's shameless plug from me.
Great promotion, sir.
Yeah.
But yeah, no, it's something that we will go through though next year. At this stage, I guess it's because you've got an exam on Monday, it's probably better to just kind of trust and accept that it's not going to change. But we will look into it later on. What about this? If y equals 10 e to the 2x, what does dy dx equal there?
Oh, I'm doing the question B. 1 second.
Mm-hmm. It's just to help you with differentiating part B, because with part B you have to differentiate.
20 e to the power of 2x.
Yes, so you're multiplying. So 20 e to the 2x. So hopefully that gives you guys scope to do.
Whenever you see like decreasing, increasing rate of change, that's always like derivatives, right?
It's the rate aspect that gives away differentiation.
Right. Okay.
Yeah, rate. That's the part that goes, oh, okay, rate of change kind of rate.
Wait, sir, could you do B as well, just to make sure? I don't have a mark scheme, just to see if we get the same answer.
So 18,000 times 0.2. Okay, times 0.1 is 1,800. Times 0.2 is 3,600. So minus 3,600 e to the minus 0.2t minus 400 e to the minus 0.1t. And then 1,000 still differentiates to 0. And then at t equals 10, dv dt equals minus 3,600 e to the minus 0.2 times 10 minus 400 e to the minus 0.1 times 10. And then that equals something.
I got decimal.
Yeah, that's okay. I mean, you would, because this answer is so irrational. It's actually just so crazy.
So I got minus £634, 35,87961. So I put a decrease of £635 per year.
You got, okay. Did it say to give? They didn't even give.
It says
Give it
give your answer in pounds.
per year.
So I just rounded it up.
Yeah, that sounds good. Minus 3,600. Let me just check. E to the minus. Oh, you rounded up. If it's pounds and stuff, I'll maybe do 2 decimal places.
Okay.
So cool. And then part 4, which I do not have space for, but I will make another copy, will be on slide 3. And it says calculate the exact value of t when v equals 15,000. So this one's an interesting question because we set v equals to 15,000. So we have 15,000, and just make that clear that it's part C. 15,000 equals 18,000 e to the minus 0.2t plus 4,000 e to the minus 0.1t plus 1,000. So let's take everything to one side, make it equal to 0. Might be easy. 0 equals 18,000 e to the minus 0.2t plus 4,000 e to the minus 0.1t minus 14,000. Fun. Oh, this looks nice. Everything is a multiple of 1,000. In fact, everything's a multiple of 2,000. Let's divide through by 2,000. 0 equals 9 e to the minus 0.2t plus 2 e to the minus 0.1t minus 7. Now we can see this is looking a bit more like a quadratic, but one thing that I don't like, which I'm hoping you guys also don't like, is the negative powers. Too much negativity. So if we multiply everything through by e to the power of 0.2t. In fact, what would we get? I'm going to ask you guys. What would we get if we multiply everything by e to the power of 0.2t?
Would you get 1 for the first value?
1, did you say?
Yeah.
As in just 1 completely?
Like yeah, 1 completely. I don't know.
Not quite, but you're close.
It'll
Explain
just
your
be
logic.
e to the power of t.
E to the power of t? Why e to the power of t?
I don't know.
How did you get it? What was your logic?
Well, I just plugged it in the calculator, and e to the power of minus 0.2 times e to the power of 0.2 is 1.
But what about 9e to the power of minus 0.2t times e to the power of 0.2t?
Oh, I get 81.
But wait, you're not timesing it by 9 e to the power of 0.2t. You're timesing it just by e to the power of 0.2t.
Oh. Would you just get the 9 then?
You just get the 9.
How does that work?
Well, you've got 9e to the minus 0.2t multiplied by e to the power of 0.2t. The e to the power of 0.2, well, we can split it up further if you like. Like that. E to the power of minus 0.2t times e to the power of 0.2t
Oh, right.
e to the power of 0,
Yeah, you add them. Yeah.
which equals 9 times 1, which equals 9. So we got that. And then the next one. Any takers for the next one?
2 times e to the power of minus 0.1t times e to the power of 0.2t.
I like that. I like how you're going through it systematically.
Which is 2 times minus 0.1 plus 0.2. So it'd be 2 times e to the power of 0.1.
Nice. That's it, yeah. So 2 times e to the minus 0.1t times e to the power of 0.2t. We add the powers. 2e to the power of 0.1t, because minus 0.1t plus 0.2t is 0.1t.
And then would you also get minus 7e to the power... Oh, wait, no, you're dividing it. No, you're timesing it. So minus 7e to the power of 0.2t as well.
That's it. Now we can see that we've got a quadratic. It's a bit clearer. Let's do this. Okay, what letter have we not used? Y. Let y equal e to the power of 0.1t. That means that y squared, which is equal to y times y, equals e to the power of 0.1t times e to the power of 0.1t, which equals e to the power of 0.2t. So we can now make the substitutions to say 0 equals 9 plus 2y minus 7y squared. Can we solve that quadratic?
You get y equals 1.2857 and y equals -1.
1.2857. 1.2857. 1.2857. Sounds familiar. It sounds almost like it's 9/7. Is that 9/7?
Yeah.
Yeah. Yeah. Okay. Cool. So, are people okay with me just writing down what the values of y are? Hopefully. Yeah. What was the other value? Sorry.
-1.
Cool. That's just using a calculator. Cool. I'm guessing that was using a calculator, or did
Yeah.
you? So okay, cool. So y was equal to e to the power of 0.1t. So e to the power of 0.1t equals 9/7, or e to the power of 0.1t equals -1. But does it? No, it does not, because e to the power of something can never be negative. Because here there are no real solutions. So we've only got this to be left with. So here we take logs of both sides. 0.1t equals the natural log of 9/7. So t equals 10 times the natural log of 9/7. And there we go.
So,
Mm-hmm.
could you go over natural logs? Because I don't understand.
Natural log is just log to the base e.
Oh, right, okay.
Means the same thing. So if you can do a normal log, then this log is no different in that respect.
Okay.
Any other questions?
No, thank you, sir.